Okay, the Wi-Fi is really, really bad in here. So I don't know how well this is going to work, but I was hoping we could play a little game together. So I've got this, I don't know if the Wi-Fi is going to be good enough for this, but I built this game and I wanted to just show you guys and then I'll talk about the game. But you have 10 seconds and you have to pick the highest number. Whoever picks the highest number wins, but you can only pick once. Oh look, I won. You can only pick once and you don't know what numbers are still coming. So the idea is you kind of have to be patient, but you can't be too patient because you don't know what's still about to come. And I'm surprised the Wi-Fi is holding on. At least for me it is. So how did I build this game? So I actually went full over engineering, and this is just a GIF of the game in case it didn't, in case the Wi-Fi didn't work. But I went full over engineering mode, and I decided to test out a bunch of cool things, such as pglite, which is a Postgres build that can run in the browser, and electric, which is a sync engine. We'll talk more about those during the talk today, but I basically have a remote Postgres database on Neon, of course, and then I've got a React front end and the Node server, and I'm using electric to do syncing of the data. So the whole thing is like real time and multiplayer, and I kind of get that for free with electric, which is again a sync engine. But then of course I still need a server to like handle the game logic and all of those things. So hopefully you find the game fun. Now on to today's talk, the Upsidedown stack, React on the server, and Postgres in the browser. So I work at a database company called Neon. We're a serverless Postgres platform, and I work on a bunch of things over there. And one thing we've been like keeping an eye on recently is this pglite project. And it really got our attention, so we decided to play with it and learn more about it. This talk was actually supposed to be given by Brian, my beloved product manager who I work with a lot, but unfortunately, or fortunately, his daughter was born a couple weeks ago and he had to stay with the family. So I'm here to replace Brian. Okay, now React on the server, that's here to stay. Over the past few years, we've seen an uprise in frameworks like Next.js and Remix, which take full advantage of server-side rendering and React server components in order to improve user experience on a number of applications. And one thing that hasn't panned out as much is bringing server stuff to the client. But with pglite, which we'll talk about today, there are certain situations where that can make sense. And we're going to talk about that today. So I'm going to focus on this idea of running Postgres in the browser. So the idea of the talk today is to learn about it and figure out when you should do this, why you would do it, and how to do it. Before, I want to do a little step back, and I want to do a little recap. Most of you don't need this recap, but let's still go through this like exercise of like answering the question, why do applications need backends? Okay, and I know you're all thinking like you already have like a million reasons in your mind, but let's bear through this and try to boil it down. Okay, why can't applications just have a front end and a database? Why can't we just build client-side apps? Wouldn't that be just so much easier? And there's a million reasons, but let's boil it down to just 3 things. Reason number 1, authentication and authorization. Good old auth-n, auth-z. Who are you? What can you do? What can you see on this application? What teams are you a part of? These questions need to be answered by something, right? And it cannot be the client. So all this kind of authorization logic needs to live on a server because we can't trust this to the client. Then, what about calling third-party APIs? Imagine you're building an app and you need to call the OpenAI API to do some like AI text summarization or something like that. Well, you're not going to do that from your client. You need to do that from a server, and you need your server to like store some third-party API secrets, and you can't do that from the client, obviously. And then finally, the third reason is abstractions and transformations and expensive computations. You don't really want to expose like your entire database's schema to your clients because you want to be able to iterate and evolve your data models and your schema over time without disrupting your UI engineering work. Furthermore, there are a ton of computations that you might need to do in an application, like image generation or algorithm crunching. For example, on Twitter, when you see the people to follow, right? You're not going to compute that list of people on the client side, right? So you do that in your server, and that's how applications have always been built, and it works. But humor me for a bit, and let's just try to think if it would be possible to get rid of traditional backends. Could we maybe come up with ways to do all of these things that I just talked about on the client? Let's go one by one. Authentication. Well, what if we use some third-party auth provider, such as Auth0, and then we use something like Postgres row-level security in order to push the authorization down to the database. If you're not familiar with Postgres RLS, it's a way for you to declare who can do what and who can see what at the database schema level. So in a way, you could get rid of your backend and push authorization to the database and push authentication to a third party, and you wouldn't need your own backend for this. What about calling third-party APIs? Well, that's not really something you're going to do from your database. I mean, theoretically, you could do it in like database functions. There's actually a recent Fireship video on YouTube. I think it's called Postgres for Everything, where he kind of goes through this idea. But yeah, I wouldn't recommend doing it from a database. So this is one of those things where you really need to do from a backend. And then finally, for abstractions and transformations, perhaps you could use like Postgres views to abstract like the parts of your schema that your client needs to be aware of. And you can push down certain types of heavy computation to the client with things like WASM and pglite. And yeah, some apps are doing that, but for the most part, it's a stretch, right? So we're not going to get rid of backends, but what we can do is go with something like this thing that I call the backendless stack, where you have your database, and you have something like RLS that I already talked about, and then you have something like PostgREST or Hasura or PostgreFile, and that sits on top of your database, and it does like authentication for you. And then you're using a framework like Next.js or Remix, which gives you your like backend for frontend with something like Next.js server actions or Vercel functions, or a really easy Cloudflare worker style product to do the things that you really need a backend for, right? But for the most part, you're not really developing this traditional backend, and you could almost call this like the backendless stack. And this stack is growing in popularity. I see a ton of like new startups. They're using this kind of pattern, and eventually they do migrate to something else. But for new apps, it works quite well. but how can you do offline support, and how can you do like maximum performance and real time and streaming and all of those things? Well, we were thinking about it and we thought, well, can we just put a database in the client? Like, will that help us with that? And of course, like, you don't have to do this first thing first. You don't really need to put a database in the client to build apps that work offline and to get maximum performance. But it is one way to do it. So let's dive in. What is our goal? Like, what do we want when we're building apps? Well, we want like our front end to have a type-safe data API, right? We want it to be like really easy for our front end engineers in their React components to ask for the data that they need and to ask for it in a type-safe way. And we want them to not be worried about caching or refetching. We want writes to be fast, ideally local first, with optimistic writes. We want to be able to offload computation to the client for things like semantic search if needed. And we want offline support to be more or less automatic or default in our framework of choice. So that's like the ideal holy grail scenario that we're trying to achieve. And so we looked at pglite. If you haven't heard of pglite, it's a wasm build of Postgres. It was actually started by one of Neon's co-founders, one of our many Postgres hackers. And now it's being amazingly shepherded by the team over at Electric SQL. The size of pglite is 3 megabytes, which can sound really, really large because it's in a web app that's quite large. But at the same time, it's really impressive that it's only 3 megabytes for Postgres. And it supports extensions, not all of them, but a fair amount. The Electric SQL team did an amazing job at making it really easy to bundle it with Vite or Next. So all of these modern front-end frameworks, you can pull in pglite very easily. ORMs like Drizzle just work. And you can do cool things like multi-tab workers where multiple tabs in your browser are talking to the same pglite database. What are the use cases of pglite? Well, one that's actually in production is this app called LubChat. It's an alternative to like the ChatGPT UI. It's similar to like T3 Chat in that you can use multiple different models, and it works fully offline. So if you're like on an airplane, you can browse through your previous conversations with the different AIs. And they're using pglite to achieve this. Another cool use case of pglite is a demo that was actually built by the Zubase DevRel team, where they're using pgvector on the client to enable semantic search on the client. So they load a small language model, and you could theoretically build an app like Linear that works offline with semantic search also working offline. So how do you use pglite? Well, it's really, really easy. Like I said, Vite and Next.js support out of the box. You just call this pglite.create function. You can choose where to store the state of the database. So you can use IndexedDB, which is faster, which is what I'm doing here. You can also just use in-memory state if you only need pglite for like an ephemeral computation. You load your SQL schema, and then you just go to town. It's just Postgres. You can run SQL queries. You can write data. You can load data. How do you use it with a sync engine? Well, you can use it with Electric SQL, which is a sync engine, and they offer this nice API which allows you to synchronize a local pglite instance with a remote Postgres database. So you just define an Electric SQL shape. In Electric SQL, a shape is basically a Postgres table with an optional where clause. And Electric will take all of the heavy work of synchronizing this shape between your local pglite and your remote Neon database. And then you get this amazing use live query React hook. So in your React components, you can subscribe to the output of any given SQL query. So in the game that we were playing before, I don't know how many of you here on the conference were able to actually open the game, but that game is powered by pglite, and anytime you pick a number in the game, I'm actually writing to a local pglite instance running in the browser, and then I have this React hook, use live query, that causes my component to automatically re-render whenever this query changes. And they're smart about it, so like they're only rerunning this query whenever there's writes to the tables that this query is reading from. So that's really nice. It works really well. Of course, inserts, updates, everything works well. Now, it's not all roses, okay? In order to enable this sync between local pglite and remote Postgres, you have to do a few very complicated things. I'm going to try and not scare everyone too much, but I had to create a Postgres view. In Postgres, a view is essentially like a it's like a query that you define over one or more tables, and anytime you run a select from that view, you're basically just running this query. And I had to create a Postgres view that combines two local Postgres tables that I also had to create, pix local and pix synced. And then I configured Electric to sync the pix synced table with my remote Postgres database, which has a pix table. The pix table, as you can guess, is where each person's game picks are stored. And then I also had to, and then I still need a server, right? I still need a Node.js server where I'm actually validating the inserts for authorization, authentication, and the game logic, right? So I have to verify that when someone picks a number in the game, that they're picking like a real number that was in the game at that moment in time, so that someone couldn't just like open the network tab and submit like arbitrary, I just picked 100, right? So all of this is extremely complex. And like I said at the beginning of the talk, this is a very over-engineered application. But it was very interesting to go through the experience just to see what it's like to use pglite in combination with Electric. So here's what I have to say of my experience. I'm going to skip through these slides. But basically, pglite on the client is very early, like it's still a very new project. And with any new such technology, you should expect a level of maturity that is not maybe production ready yet. I actually ran into a pretty hard bug, but Sam Willis, the maintainer of pglite, he was amazing. He fixed the bug for me over the weekend and saved the implementation of the game. And the complexity around synchronizing local pglite with a remote Postgres instance is still very high. So the developer experience is not up to par yet. So what is our alternative? So how do you build an app with all of those things that I mentioned before, like client-side, type-safe, data API, and very fast writes, very fast reads, automatic caching? Well, you can just use a sync engine, right? PowerSync, Zero, Electric. I think there's one called LocalStar as well, or SyncStar. Those work, those work without a database in the browser, right? You can use Electric, you can use Zero. They have much smaller bundle sizes, and with a sync engine, you can get many of the things that we were looking to try to get out of pglite. So your architecture might end up looking something like this, where you have your database and you have a sync engine enabling all of those things. Automatic data API that's fully type safe, automatic caching, etc. So with Electric, how do you do this with Electric? You define a shape. I already explained what a shape is. You take some Postgres table, some optional where clause, and then Electric will make that shape available to your React component. If you're familiar with other sync engines, it's fairly similar to others. and your component will automatically re-render whenever the payload of this shape changes. And of course, they're piggybacking on Postgres logical replication in order to do this. And for writes, you have a few different options for writes. For a lot of applications, you should just do online writes because you don't actually need like local first writes that work offline. But there's also a way for you to do optimistic local writes using the use optimistic hook in React. The API for Electric is still not at like a level of developer experience that I would consider just 1.0. But Kyle Matthews, one of the members behind Electric SQL, you might recognize him from his work on Gatsby in the past. He's working on this library called 10-stack optimistic. By the way, the name of the library is subject to change, which gives you this much nicer API where you just define a collection and you configure the collection, which I'm not showing here on the slide, but you configure the collection, you attach a collection to a given Electric SQL shape, and then you get back these insert, update, delete functions that are fully type safe and that just make the experience of writing React components much easier with, of course, the front-end developer not having to worry about caching, refetching, all of that. So the developer experience of sync engines is getting there. Aaron Budman is actually giving a talk tomorrow about Zero as well. All of these products are kind of still like more on the beta side, and the space is evolving quickly, but the developer experience is finally getting to a level that I think is quite reasonable. I fully expect in next year's React Miami for there to be more and more discussion about sync engines. So yeah, we should pay attention. I expect application development platforms like Vercel, like Cloudflare, to start taking these sync engines, maybe running them for you, or integrating with these sync engine clouds. And so I fully expect that like engineers in the future building their first apps are going to have sync engines available to them without them even really knowing what a sync engine is. I hope that platforms like Vercel can make it like just so native and so automatic and so default that we're all using them and reaping the benefits of them without having to worry about how to run them and even knowing what they are. So that's it from me. I will just mention one more thing. Tomorrow, Henry and I are hosting a 5K, so join us at the lobby tomorrow at 7 a.m. and we'll do a very casual, slow pace 5K around the waterfront. That's it from me. Thank you all. Please reach out.